We're going to multiply polynomials today, which sounds like a new concept, but is really just an application of something that you've done in the past. So here we are multiplying three monomials together. You're going to multiply the coefficient part, so that's 1/4, times 1, times -12, which gives me -3. Then we're going to multiply the s's together. S to the second times s to the first times s to the first. Remember, the rule is when you're multiplying bases that are the same, you add the exponents. So that's going to give me s to the fourth. And then t squared times t to the first times t to the second is going to give me t to the fifth. This example multiplies a monomial times a trinomial. And again, this is a concept that you've done before. It's just the distributive property. So the 4 is going to be multiplied by the 3x squared to give me 12x squared. The 4 is going to be multiplied times the 4x to give me 16x. And the 4 is going to be multiplied by the 8 to give me -32. Just check to make sure that you don't have any like terms that you can combine. All right. Here's one that you should try, so pause the video, do it, and then come back and look and see what your answer is. Again, this is the distributive property. It's just that the terms are a little more complex. So half of 6 is 3. X squared times x is x cubed. And y to the first times y to the first is y to the second. Skip over to the next term. And half of 8 is 4. X squared times x squared is x to the fourth. And y times y squared is y cubed. All right. This is going to be a little bit different. This is a binomial times binomial. One way to look at this is to split it up. Let's take the first term here times the second polynomial. So I can rewrite this as x times x plus 3. And then I can go back and pick up the second term of the first polynomial, which is a positive 2. And it also gets multiplied times x plus 3. And now I do the distributive property twice. X times x is x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. Check to make sure that there aren't any like terms. Well, in this case, there are. They are right here. So this is going to give me x squared plus 5x plus 6. All right, let's take it a little bit further. This time we have a binomial times a trinomial. So it's going to be the same premise, the same idea. I'm going to take the 2x and I'm going to multiply it times the entire polynomial behind it. All right, that should be a little curve there, not straight up and down. So that's going to be times 4x squared minus x plus 6. Come back and pick up the second term. Now be very careful because that's a minus sign there. So you might want to change that to plus the opposite and make this plus a -3 times 4x squared minus x plus 6. That little minus sign there is probably what's going to cause some people some trouble. So please be very mindful of that, saying that you're going to subtract everything that 3 is multiplied by. So here we go. Do the distributive property here. And that's going to give me 8x cubed minus 2x squared plus 12x. Take the -3, multiply it, and that's going to give me -12x squared. Negative times negative is positive 3x minus 18. Go back and see if there are any like terms. So I always put them in my answer in standard form, which means in order based on its exponents. So I'm going to start with the x cubed. Are there any other x cubes here? No, so that's going to give me 8x cubes. Next comes x squared. Well, I have an x squared here and an x squared here. So that's going to give me -14x squared. Then come the x's. I have x's here and x's here, which is going to give me 15x. And then I have my constant term down here, so I just leave that. There's actually a cute little acronym that we can use for multiplying binomials together. It's called FOIL. And FOIL stands for first, outer or outside, I for inner or inside, and L for last. Okay, and this is how this works. Ready? The first term of this binomial times the first term of this binomial. It gives me s squared. The terms furthest on the outside, which gives me minus 3s. The terms closest to the inside, which gives me positive 4s. And the last term of this binomial times the last term of this binomial, which gives me negative 12. Check to make sure that they, if they have any like terms. Many times it's the two in the middle that are like, and that's going to give me s squared plus s minus 12. Now, I really like this because I think it's cute and easy to remember, and plus I think this looks kind of like a little happy face smiling at you that you did it right. Here's one that's a little bit tricky because it's asking me to square a binomial. A lot of times we like to take this square and just apply it to each one of these terms, but we don't have a rule that allows us to do that. We didn't encounter any rules with exponents that allowed us to do that with addition or subtraction here. So my suggestion would be to take this and write it. This is really saying x minus 3 times itself, which is another x minus 3. And that is going to use FOIL. So ready? First, outside, inside, last. See how easy this is when you do this? There's my like terms right there. So this is going to give me x squared, minus 6x plus 9. All right? You can set this up different ways. I like to do it the way I just did it. I like to put my polynomials right next to each other and basically just do the distributive property over and over again. You can do it this way, okay? This has your trinomial on the top and it has your binomial on the bottom, okay? So what I'm going to do is I'm going to take this, and then I'm going to multiply. I'm basically finding the area of each one of these little boxes. So this is a 2x squared by 5x, which gives me 10x cubed. This is a 10x by 5x, which gives me 50x squared. And this is a negative 6 by 5x, which is negative 30x. Do the same thing down here. Normally what happens is these two are like terms and can be added together to give me 56x squared. These two are like terms, which basically add together to give me 0x, so that's gone. And you have my final answer. You're going to get the same answer whether you do the distributive property or you set it up like this. You can also set it up vertically. So you can put one polynomial on the top, the other one underneath it, and then do like you normally do multiplication. Take this term right here, multiply it times the negative 6, times the 10x, times the 2x squared, and there's those answers. Then go and take the 5x. Now remember, a lot of you sometimes put like an x here or a circle or something. You do something to hold that spot and say don't use it. All right, and then I'm going to multiply the 5x times the negative 6 times the 10x and times the 2x squared. And then your like terms are lined up one right underneath each other. Okay, you may use any of those methods that you would like. Okay, we're going to expand on something we talked about just a minute ago. This is x plus 3 cubed. So that's going to be x plus 3 times x plus 3 times x plus 3. Now, this isn't done all in one step. If you had 2 times 3 times 4, you would multiply two of those together first. So 2 times 3 is 6. Then you would take that answer, 6 times 4, and you would get 24. That's what we're going to do here. So we're going to ignore one of these for just a minute. We're going to do FOIL right here. So ready? First, outer, inner, last. That's going to give me x squared plus 3x plus 3x plus 9 which simplifies to x squared plus 6x plus 9. Now we're going to take that answer and we're going to multiply it times x plus 3. Okay? And then we're going to do the distributive property. Ready? X squared times x is x cubed. X squared times 3 is 3x. 6 times, oh, that's 3x squared. Okay, 6x times x is 6x squared. 6x times 3 is 18x. Now move on to the 9. 9 times x is 9x, and 9 times 3 is 27. Combine your like terms. These two are going to go together. These two are going to go together. And your final answer is going to be x cubed plus 9x squared plus 27x plus 27. And there we go. You can apply this. Here's a rectangle. And it says the width of the rectangular prism is 3 feet less than the height. So here's the height, okay? And so this is 3 feet less. And then the length is 4 feet more than the height. So I just did the dimensions there. Write a polynomial that represents the area of the base. Well, the base is h minus 3 and h plus 4. We know the area of a rectangle is length times width or base times height. So we substitute those in. We use FOIL. First, outer, inner, last. Okay? Combine your like terms with your outers and inners, and there's your answer. Okay?